Welcome back to the Deep Dive. Today, we're diving into something that's probably on everyone's mind if you've been following the whole LLM explosion.
Oh, yeah.
How do these things actually work
Right.
without melting our computers?
Yeah, without, like, catching fire.
It's like trying to run a city on a hamster wheel, billions of parameters, mountains of data.
It's a real challenge even for the experts.
Yeah.
Running these massive models efficiently is a huge part of making them usable
Right.
for everyday folks like you and me.
For sure.
Because, let's face it, nobody wants to wait a week for a simple response.
Totally.
Or break the bank on electricity bills just to chat with an AI.
Exactly. So let's unpack this, shall we? We've got a stack of research and articles.
Okay.
All about LLM efficiency.
All right.
Our mission.
Yeah.
To figure out what the bottlenecks are.
Okay.
What clever tricks researchers are using to overcome them. And why you might not need a supercomputer.
Right.
To play with this tech after all.
Sounds like a plan.
Okay.
And to start, we need to be honest.
Yeah.
LLMs are resource hogs.
Okay.
They crave computation, memory, speed.
Yeah, the whole 9 yards.
The whole 9 yards.
Okay, but how do we even measure LLM efficiency?
Yeah.
It can't just be about how fast my laptop fan is spinning.
Definitely not. There are a bunch of key metrics.
Okay.
But let's focus on the ones that really matter for understanding the big picture.
Okay.
First up, throughput.
Okay.
Think of it like a highway.
Oh.
The wider it is,
Yeah.
the more cars,
Okay.
or in this case, tokens per second,
Uh-huh.
it can handle.
Okay.
Then there's latency.
Okay.
How long it takes to get a response from the model.
Right.
Nobody likes lag, right?
Right. So throughput is about capacity,
Yeah.
and latency is about speed.
Exactly.
Okay.
Two sides of the same coin.
But what about the actual space these models take up? Like, do I need a warehouse just to store one?
That's where memory footprint comes in.
Okay.
It's all about how much digital real estate this behemoth needs.
Gotcha.
And then we've got flops,
Okay.
which stands for floating point operations per second.
Okay.
Basically, it's a measure of raw computing power. Think horsepower for your computer.
It's like judging a car.
Exactly.
You've got a horsepower, fuel efficiency, cargo space.
It all matters.
It all matters. But let's get back to that memory issue for a sec.
Okay.
Remember the KV cache from our earlier deep dives?
Yes.
It's like a cheat sheet for LLMs, storing previously computed results to speed up that whole attention process.
Right.
But doesn't it get absolutely enormous?
You're spot on. The KV cache is essential for fast retrieval.
Yeah.
But it can become a real memory monster.
Okay.
Gobbling up valuable space.
Uh-huh.
It's a classic trade-off, speed versus storage.
Yeah.
And that's where things get really interesting because researchers are coming up with all sorts of ingenious ways to deal with this.
Okay, spill the beans.
Right.
What are they doing to make these models more memory-friendly?
Well, one approach is model parallelism.
Okay.
Instead of trying to cram the entire LLM onto a single computer,
Right.
we split it across multiple devices.
Okay.
It's like having a team of movers
Uh-huh.
tackling a giant piece of furniture.
Right.
Each person handles a specific section.
I love that analogy.
Yeah.
So it's all about dividing and conquering.
Exactly.
But how do we actually split up the model? Do we just chop it in half?
Not quite.
Okay.
There are different ways to do this,
Okay.
each with its own pros and cons.
Okay.
One common approach is tensor parallelism.
Okay.
This involves dividing those massive matrices of parameter,
Uh-huh.
the heart of the LLM,
Yeah.
across multiple GPUs or TPUs.
So instead of one superpowered GPU sweating it out,
Right.
we have a whole team of them working together.
Exactly.
Like a well-oiled machine.
Teamwork makes the dream work.
I like it. I like it.
And then there's pipeline parallelism.
Okay.
Think of it like an assembly line,
Right.
where each device handles a specific stage of processing.
Okay.
One device might be responsible for encoding the input text,
Okay.
another for running the attention mechanism, and so on.
Okay, so we've got this digital assembly line humming along.
Right.
But are there any potential hiccups with this approach?
There can be.
Okay.
One thing to watch out for is what's called a pipeline bubble.
A pipeline bubble.
Yeah, imagine a worker on the assembly line
Okay.
waiting for parts to arrive
Okay.
before they can continue their tasks.
Okay.
That idle time is a pipeline bubble.
Gotcha.
And it can slow things down.
So we need to make sure the flow of information is smooth and continuous.
Exactly.
No bottlenecks.
No bottlenecks.
This is fascinating stuff. But before we get too carried away, let's move on to something that sounds completely counterintuitive.
Okay.
Quantization.
Yeah.
Are we really talking about making things more efficient
Yep.
by making the numbers unhelpless precise?
You heard that right. Instead of using super detailed numbers, we can often get away with using smaller, less precise ones.
Okay.
It's like using a lower resolution image.
Right.
You might lose some detail, but the file size is way smaller, and it loads much faster.
Okay.
And the surprising thing is,
Yep.
it often doesn't impact the accuracy as much as you'd think.
Hold on. You're telling me we can shrink these models
Yeah.
and speed them up
Uh-huh.
Just by rounding off a few
You
numbers.
got it.
That sounds like digital magic.
It's not quite that simple.
Okay.
But you've got the right idea.
Okay.
There are different approaches to quantization.
Right.
Post-training quantization happens after the model's already trained,
Okay.
while quantization-aware training involves training the model knowing it'll be quantized later.
So it's like teaching someone to navigate with a compass instead of relying solely on GPS.
Yeah.
It might not be as precise,
Right.
but it gets the job done.
Exactly.
And are there any specific frameworks or names we should know about in the quantization world?
Absolutely. There are frameworks like GPTQ and GGM-LGGUF.
Okay.
Those are definitely names to drop if you want to impress your AI friends.
Noted.
All right?
Okay, so we've talked about making the models themselves smaller
Yep.
and more efficient.
Right.
But what about the way we actually interact with them?
Okay.
Can we optimize that as well?
You're thinking like a true efficiency enthusiast.
Oh, yeah, always.
And the answer is yes.
Okay.
Remember prompt engineering from our earlier deep dives?
Oh, yeah.
Turns out how you phrase your prompts
Yeah.
can have a huge impact on the computational costs.
Right.
A clear, concise prompt
Right.
will almost always lead to faster and more accurate results
Right.
compared to a rambling, ambiguous one.
It's like giving clear instructions to a chef.
Uh-huh.
If you know exactly what you want,
Yeah,
they can whip it up much faster than if you're vague and indecisive.
exactly. And there's another cool development in this area
Oh,
called compressed prompts.
compressed prompts?
Researchers are figuring out ways to encode prompts more efficiently,
Okay.
creating shorter representations that still give the model all the info it needs.
Okay.
It's like using a secret code to communicate complex ideas.
So it's all about finding more efficient ways to talk to these language models.
Exactly.
I'm sensing a theme here.
What's that?
It's all about optimization.
Yes.
Whether it's the model itself,
Uh-huh.
how we use it,
Yep.
or even how we communicate with it.
You're spot on.
Okay.
And all this effort is leading to some incredible possibilities.
Okay. Like what?
For example, we're seeing the rise of on-device LLMs.
You mean running these massive models
Yeah.
on our phones or smart devices?
You got it.
But I thought we needed supercomputers for that.
Not anymore.
Really?
As LLMs get more efficient, we can start to deploy them on less powerful hardware.
Wow.
Imagine having a sophisticated language model running right on your phone, capable of real-time translation,
Yeah.
personalized content creation,
Uh-huh.
or even assisting with complex tasks,
Okay.
all without needing an internet connection.
Whoa, that's mind-blowing.
Yeah, it's pretty amazing.
What are some of the challenges of running these models on devices with limited resources?
Well, one of the main challenges is power consumption.
Okay.
LLMs are computationally intensive.
Right.
And running them on a battery-powered device
Yeah.
can drain the battery quickly.
Right.
Researchers are working on ways to reduce the energy consumption of these models,
Okay.
such as using more efficient hardware
Uh-huh.
or optimizing the software to run more efficiently.
That makes sense.
Yeah.
So it's not just about shrinking the model.
Right.
It's also about making sure it plays nicely with the hardware it's running on.
Exactly.
What about memory constraints?
Yeah.
Our phones don't have nearly as much memory as a server.
That's another hurdle.
Okay.
Smaller, more efficient model architectures,
Uh-huh.
as well as techniques like model pruning,
Model pruning.
where we selectively removed less important connections
Okay.
in the neural network,
Right.
are key to making this work.
Okay.
It's like decluttering a house,
Uh-huh.
getting rid of things you don't need to free up space.
So we're basically Marie Kondoing these models to make them fit on our phones.
Exactly.
But isn't there a risk that we'll lose some of the model's capabilities if we prune too much?
There is a risk, yes.
Yeah.
But it's a matter of finding the right balance.
Okay.
If we prune too aggressively, we might hurt the model's performance.
Right.
But if we're careful
Okay.
and use sophisticated algorithms to guide the pruning process,
Yeah.
we can often shrink the model significantly without sacrificing too much accuracy.
Like finding the sweet spot between a model that's lean and mean,
Yep,
but still capable of handling the task at hand.
exactly.
This whole idea of on-device LLMs is incredibly exciting.
It is.
What are some of the potential applications you're most excited about?
One area that has huge potential
Yeah.
is personalized education.
Personalized education.
Imagine a language model that can adapt to your learning style,
Uh-huh.
provide personalized feedback,
Okay.
and even generate customized learning materials.
Wow. That would revolutionize the way we learn.
I think so.
No more one-size-fits-all textbooks or lectures.
Right.
And what about healthcare?
Oh, yeah.
I can see on-device LLMs playing a big role there, too.
Absolutely. Imagine a world where your phone could analyze your symptoms,
Okay.
provide personalized health recommendations,
Uh-huh.
and even help you communicate with your doctor more effectively.
Wow.
The possibilities are truly endless.
It sounds like on-device LLMs have the potential to transform almost every aspect of our lives.
I agree.
But as we wrap up part 2,
Okay.
I think it's worth noting that all this progress
Uh-huh.
comes with some important considerations.
For sure.
We can't just focus on efficiency
Right.
and forget about the bigger picture.
You're right. There are some important trade-offs to consider.
Okay.
And we'll delve into those in our final part.
All right. Stay tuned.
Welcome back to the deep dive. We've been exploring all the amazing ways researchers are making LLMs more efficient.
Yeah.
But as with any powerful technology,
Uh-huh.
there are some important trade-offs to consider.
That's a crucial point.
Right.
It's not just about blindly shrinking these models and cranking up the speed.
Right.
We need to be mindful
Yeah.
of the potential downsides.
Okay, so let's talk about those downsides.
Right.
What are some of the things we need to be careful about
Yeah.
as we push for greater LLM efficiency?
One major consideration is the potential loss
Okay.
of accuracy or capabilities.
Right.
As we strive for smaller, faster models,
Uh-huh.
we might unintentionally sacrifice some of the nuance and complexity
Okay.
that make LLMs so powerful.
I see.
It's like compressing a high-resolution image too much.
Right.
You save space, but the image quality suffers.
So it's a delicate balancing act.
It is.
We want efficiency.
Right. But not at the expense of the core functionality
Exactly.
that makes these models so valuable.
Uh-huh.
What are some of the factors that influence this trade-off?
Well, the specific task or application plays a huge role
Okay.
for certain tasks,
Yeah,
like
yeah.
simple question answering
Mm-hmm.
or text summarization.
Okay.
A smaller, more efficient model might be perfectly adequate,
Right.
but for more complex tasks
Right.
that require deep reasoning
Right.
or nuanced language understanding,
Uh-huh.
a larger, more computationally intensive model might be necessary.
So it's like choosing the right tool for the job.
Exact.
You wouldn't use a hammer to fix a watch, right?
You got it.
And just like with any tool,
Yeah.
there's a learning curve involved in understanding the strengths and limitations
Uh-huh.
of different LLM architectures and optimization techniques.
For sure.
It sounds like we need to be careful not to get too caught up in the numbers,
Right.
flops memory footprint, and so on.
Yeah, all those metrics.
We also need to pay attention to the qualitative aspects of these models,
Sure.
their ability to reason, generate creative text,
Yeah.
and truly understand the nuances of human language.
You've hit the nail on the head.
Okay.
The pursuit of efficiency should never overshadow the fundamental goals of artificial intelligence,
Right.
which are to create systems that can understand, learn, and reason like humans.
It's a good reminder that efficiency is a means to an end,
Exact.
not the end goal itself.
Right.
It's about enabling us to do more with these powerful tools
Yep.
to unlock new possibilities and applications that benefit society.
I agree.
And speaking of benefits,
Okay.
we've talked a lot about the technical side of things,
Uh-huh.
but what does all this mean for the average person?
Right.
How will these advancements in LLM efficiency actually impact our lives?
Well, for starters,
Yeah.
it means that LLMs will become more accessible to a wider range of people
Okay.
as these models become more efficient.
Uh-huh.
They'll require less expensive hardware to run.
Right.
Which means that individuals, small businesses, and organizations with limited budgets
Right.
will be able to leverage their power.
That's a huge step towards democratizing AI.
It is.
What are some of the specific ways we might see this play out
Yeah.
in our everyday lives?
Imagine a world where you have access to a powerful language model right on your phone,
Okay.
capable of providing real-time language translation,
Right.
generating creative content, or even helping you write better emails.
Okay, that's pretty cool.
Yeah.
But let's go beyond personal use.
Okay.
What about the bigger picture?
All right.
How could these advancements shape industries
Yeah.
or even society as a whole?
Think about education, healthcare, customer service,
Uh,
even scientific research.
okay.
Virtually every field can benefit from more efficient LLMs.
Right.
They can automate tasks,
Yep.
personalize experiences,
Wow.
and help us make better decisions.
It sounds like we're on the cusp of a major shift
Yeah,
in how we interact with technology.
I think so.
But with all this talk of progress,
Mm-hmm.
it's important to remember
Yeah,
that there were always potential risks and challenges.
for sure.
What are some things we need to be mindful of as we move forward?
One concern is the potential for bias.
Okay.
If we're not careful,
Yeah.
we could end up creating models that reflect and amplify existing societal biases.
Right.
Another challenge is ensuring that these powerful tools are used responsibly and ethically.
Okay.
We need to establish clear guidelines and regulations to prevent misuse.
So it's not just about making the technology work.
Right.
It's about making sure it works for good.
Exactly.
And that requires a collaborative effort between researchers, policymakers, and the public.
Absolutely. The future of AI is not predetermined.
Right.
It's something we're actively shaping with every decision we make.
Yeah.
So let's make sure it's a future we can all be proud of.
Well said. And on that note, I want to thank you, our listeners, for joining us on this deep dive into the world of LLM efficiency.
It's been great.
We've covered a lot of ground, from the nitty-gritty technical details to the broader societal implications.
Yeah, it's been a fascinating journey.
And remember, the world of AI is constantly evolving, so stay curious.
Keep learning.
Keep exploring.
For sure.
And let's continue to learn and grow together.